All right, so you want to really get a handle on modern telecommunications, right? But without just, wading through textbooks forever.
Exactly. Theory is one thing, but actually doing it, that's different.
Well, today we're diving deep into the LHP 4000 Advanced Telecommunications Systems Laboratory. And our mission, really, is to show you how this setup offers a kind of hands-on shortcut.
Yeah, a shortcut to mastering these complex networks, everything from basic cabling right up to, well, global stuff.
So it's less about memorizing definitions, more about true understanding.
Precisely. What's fascinating, I think, is its breadth, but also the practical focus. It pulls together so many different fields.
Like what specifically?
Well, you've got your fundamental network protocols, obviously, but then also 5G, IoT, even satellite systems. It's designed to give you those aha moments.
Okay, where
Yeah.
you don't just learn what it is, but why it matters.
Exactly. Why it's essential for, how everything's connected today. It makes the invisible connections sort of visible,
Yeah.
tangible.
Okay, let's unpack that. The core of this, I gather, is the Icarus Digital Telecom Training System.
That's right. Icarus.
Now, network simulators aren't totally new, but you're saying this is different.
Oh, definitely. It's not just drawing diagrams on a screen. This is a networked lab. It lets you simulate almost any network you can think of.
Like LANs, WANs.
Yeah, LANs, WANs, wireless, voice over IP, even the latest 5G mobile networks. It's basically a dynamic sandbox.
A sandbox for building and testing real communication scenarios.
You got it. And it connects to the bigger picture, right? It allows for really comprehensive, like, A to Z training.
A to Z, so starting right at the beginning.
Absolutely. You might start with something foundational like structured cabling. There's the PT CD41 workshop kit for that.
Okay, structured cabling. Sounds basic. What's the aha moment there?
Well, you're physically building subnetworks, crimping cables, testing connections with real tools. Then you introduce faults.
Ah, so you actually troubleshoot physical problems,
Yes.
like crosstalk or a bad crimp.
Precisely. Stuff that looks simple on paper but can totally wreck performance in the real world. You learn the physical layer secrets.
Gotcha. So from the physical wires up,
Yeah.
then what? Understanding the protocols.
Right. You move on to the core TCP/IP and OSI models. But again, it's interactive. You use fault testing exercises.
So you're not just reading about layer 3 errors, you're like causing them.
Exactly. You inject a routing error, say, and then you trace its impact across the simulated network.
Yeah.
See how it cascades.
Okay, that sounds way more engaging than a textbook diagram.
Yeah.
Builds that muscle memory for troubleshooting.
That's the idea. It's invaluable out in the field.
Now, here's where, for me, it gets really interesting. The cutting-edge applications. You mentioned IoT.
Yes, the PT4609 WNS. That's the wireless network system for IoT.
And it's got, what was it? A lot of sensors?
An astounding number, really. 37 different sensor modules. And 5 actuators, too.
Whoa. So what do you do with all that?
You learn to collect data, analyze it, develop actual smart applications. Think like building a smart building system.
Using real tools.
Yeah, using open source platforms like Home Assistant, you're integrating temperature, light, motion sensors, analyzing the data, maybe using some basic AI.
And then controlling things with the actuators, like lights or heating.
Exactly. It connects data science, AI, and practical engineering. You see the whole life cycle.
Okay, that's a huge leap from just plugging in cables. But what about going even bigger? Global scale, satellites, fiber optics. That seems harder to get hands-on with.
It does, but that's where the next level of trainers comes in, like the PT18203 satellite communication trainer.
What does that let you do? Just simulate signals?
No, much more. You simulate the full uplink and downlink process. You're actually transmitting audio, video, data simultaneously.
Seriously. And you can study things like signal delay.
Yes. You see the real-world impact of latency on, say, a live video feed over satellite. You study telemetry, interference, and learn how to mitigate it.
Wow. And fiber optics.
Similar principle. There are dedicated fiber optics trainers. You're not just learning theory, you're physically preparing the fiber.
Like stripping, cleaving.
Stripping, cleaving, fusing, all of it. Then you use tools like an OTDR to measure signal propagation and troubleshoot problems, like finding a tiny break kilometers down the line.
Okay, those are definitely skills for building the big infrastructure. Precision work.
Absolutely. Indispensable skills.
So let's tie this all together. What does this mean for you, the person listening, wanting to get into this field or upskill?
Well, I think this deep dive really shows how these kinds of comprehensive training systems are closing that gap,
The gap between just knowing the theory and actually having the practical skills the industry needs.
Exactly. The skills demanded by this really complex world of telecommunications, being able to simulate, build, troubleshoot everything from the physical cables up to 5G, IoT, satellite links.
All in one hands-on environment. It sounds pretty transformative.
It really is. The ability to experience these technologies, not just read about them, changes how you learn.
So as our world gets more and more interconnected, what's the final thought here?
I guess the question becomes, how will these advanced hands-on training methods keep evolving? How will they continue to shape the next generation of innovators who need to build and manage the communication tech of tomorrow? It's really about preparing people for challenges we might not even fully see yet, right?